Anyway, this is ITS128, and today is the beginning of the last week of class. It's Tuesday, December 8th, and let me share my screen. And so we are down here the last week, and we're gonna look at chapter 12 today. Let me put the chat up in case anybody wants to say anything. All right, so I thought that for this course, everything we covered up to and including chapter 8 are important basics of Python. It's how to write programs and write code, and you can write code to do anything after you master chapters 1 through 8. Chapter 9 is on classes is very useful when you are on a team and you want to write reusable code, okay? And you want to have abstract data types, and so you want to hide stuff, and you want to only make what's visible, or only make what's important be visible. Now, and I kind of skipped chapters 10 and 11 because of time, but chapter 12 is pretty important because it's how to interface with files. It's how to read files on your computer and how to write files onto your computer. And that's kind of the last link that you need, the last kind of thing you need to know how to do to be able to write any size program that kind of pretty much does anything. I mean, you can write you can write anything, because you can create files, and your program reads the files, does all kinds of stuff, and then writes out a file. And if a program takes 2 hours to run, you're not sitting there at the command line, or running a Python program, waiting for the thing to finish. So today I'm going to cover pretty much all of chapter 12, although I'm not going to get too much into binary data because that's kind of complicated. That would be like manipulating images and so on. And then I'm going to round out the week by finishing up these last 3 labs. I think I'm going to be able to get to do the first one today, but maybe the last one's is pretty big and pretty long, and will probably come at the end. All right, so we start by sort of seeing and understanding how Python reads files and how it writes files. So there's this open function, and you execute this open function, and as a argument, you give it a file name. Okay, let me make this a little bigger. And then so you can think of this kind of like a class, and you've created an object of this class type, and it's an object that's somehow attached to the file journal.txt, and then with this object comes along a method called read, and when you execute the read method of this object, that returns the contents of the file. So if it's a text file, it's going to return a great big text file with a bunch of characters in it, and that's the contents of the file. So if you execute this, you can kind of see that creates an object called my journal. This takes it reads it up and sticks it into a variable called contents, and then here is where it might print out the contents. All right, so so this sort of summarizes what has happened. So here, for example, it prints opening file, my text file, and then so this executes, and now you have this object called f, and with f comes along this function with this method called read, and then when you're all done using the file, you should close it. So there's this close method that comes along with an object, the open class, the objects that are created from the open class, and that closes the file. And so here, let's say the contents of the file is this, and so when this thing runs, it's going to first print out opening file my text, okay, and then it's going to print out reading file my text, and then it's going to print out closing file my text, and then down here it actually prints out contents. Contents is this big string variable. It's a string type variable which includes all of this, includes all of that. So that's inside contents. And so when we print out contents, here we say first we do a line feed, then we print out contents of my file.txt : and then another line feed, and then it prints out the characters of contents. And so that's why we see this here, and this is exactly the same as this here. All right, it's pretty simple. So if your file, if the file you're opening is in the same path or in the same directory as your Python program, then you can just say this. But if it's not, you may have to do something like this, okay, where you're actually, if the file that you want to open is someplace else, you may have to, put this path thing here in front of the file. But you don't need to put this anyplace else. I mean, you don't need to put it here, for example. This just, once it's created, once this f is created, then from then on, you don't need to refer to the path to the file anymore. There's this, read and read lines. Okay, the difference between read and read lines is, now read just reads everything. It reads all the characters up and it sticks it in to the variable. It's this reads all the characters up. Doesn't matter how many lines it is, it reads it all in one fell swoop and stores it into here. Whereas read lines will actually return a string. I mean a list of strings, and each string is a line of the file. So it assumes that you have this text file that has the /n characters in there to indicate line feeds, and so there's lines and then there's line feeds. And so what read lines does is it actually assumes line feeds, \n, and it returns a list, and it's a list of strings. Okay, so that can be more convenient. Both methods, you can include an optional argument which specifies the maximum number of bytes to read. Okay, so you can go through these participation activities, complete the statement to open this file. Well, it's like this down here. It's just open. Well, it's just this, isn't it? Yes. Here you want to read up. You want to read up as many as 500 bytes, or because it could be less than 500. So you just do read parentheses 500. So that's the argument. No, you want to do myfile.read, myfile.read 500. I think that's right. Yeah, it is. And complete the program by echoing the second line of the readme text. Okay, so we're using this read lines method. Okay, first, read up the we open up the file, assign it to this my underscore file name, and we invoke this read lines method. Okay, so now this is going to be a list. It's going to be a list of lines, and we want to print out the second line. Well, that's going to be lines left square bracket 1, because 1 is the second one, 0 is the first one. So it would just look something like that. Yes, okay. So here's an example of a little program that calculates the average of data values stored in a file. So the file looks like this. It's got these numbers here, but they're actually strings, right? They're strings because any text file has got strings. It's got strings that could look like numbers. These represent numbers, but they're actually it's actually the 1 character followed by the 0 character followed by the 5 character. Anyway, this takes care of converting those to integers. But here we this is the file. We open it up and set this f object name to it. We do this read lines, f dot read lines, and so now lines is a list. This is the first item, second item, third item. That's what it's going to be. And then here we loop through all of these, and so we grab them one at a time, one line at a time, and this is going to convert that string 105. It's going to convert that into an actual number, into an actual integer 105. And it sums it up into this total variable, starts out at 0. And then at the end, we can just count the number of lines because that's how many numbers there are. And so that's the denominator. So to compute the average, it's the total divided by the number, and you get the average AVG, and so it prints that out. All right. So iterating over the lines of a file, yeah, this is how you would iterate over the lines of a file. You open it up. Oh no. What this is saying is that when this opens up, it's actually an iterable itself. You don't, it's like you don't need to do that read lines thing. You can just, this is already going to be a list of lines that you can loop through this way. Okay, so normally you might put in here, well, you would do something like this, or you do f read lines, and then this would be lines instead of f. But it turns out that you can actually just go straight to that. This for in syntax works for iterating over the lines of a file. All right, writing files. So if you're opening it up to read, you don't need to put a second argument. But if you're going to open it up to write, you got to put a second argument, and you have to say W for write. Okay, so this, and so once you do this, then the object that's created has a different set of methods. It's got a write method, and it also has like a write lines method or something. I think. Flush. No, it's just write. Just write, and then you actually write the new line character. All right. So here, for example, you're opening up a new file. And if the file does not exist, when you're doing W, if the file does not exist, it creates it. Okay, it creates a brand new file. If it does exist, it's going to write over the file. Okay. So it's kind of like it opens it up, it erases it, and then it writes over it. So here we are simply going to write these set of characters here into the file. And so it's going to write this example string followed by a new line, followed by a couple of spaces, followed by the word test with 3 periods. So that's why it looks like this. It's got this, a new line, got a couple of blanks there, and then it prints out this. And then this closes it. So in this case, you close it. The reason you close it is in case there's some other program in the system that wants to use it. Maybe you have another program in the system. You have another program that's running that wants to use it. So that sort of releases it. It closes everything up and releases it. So here's an example. The write method only takes a string. So if you want to print out some numbers, you got to use this str function. So to write out 5.75, you got to use this str function like this. Okay, so the write just writes one character at a time. If you want to write out a new line, you actually have to write that out like this. So there's reading, there's writing, and there's also appending. So back up here when you're reading, you actually can use you can say R if you want to, comma R, but if you don't put anything there, it assumes R. But you can put R or W or A. Now what A is A is append. So if you have a file and you have some stuff in there and you want to add some stuff on the end, then you would open it up with A. And then it positions the write head at the end. And so then when you do a write function, use the write method, it'll append it onto the end. Again, if the file is missing, then it starts it creates a new file. So with both W and A, if the file is not there, if it doesn't exist, then it creates a new one. All right. Now you can also use this plus character if you want to read it and then write. You may want to read it all up and then write. And so it's kind of a little bit confusing. It's like this means the same as this, sort of, but not really. So I searched the web, and this is kind of the difference between there's R plus, W plus, A and A plus. And so it's the pluses that are confusing. So R plus is for reading and writing, but the stream is positioned at the beginning of the file. So if you start writing, it's going to start writing at the beginning of the file. Whereas A plus would start writing at the end of the file. The stream is positioned at the end of the file. For R, the file has to exist, whereas with W plus, the file is created if it doesn't exist. No, yeah, it's created if it doesn't exist. And if it does exist, it looks like it's truncated. What? So anyway, there are subtle differences with these difference between W plus and R plus and A plus, but the plus means both reading and writing. All right, so here you can answer these questions. A plus data will be appended to the end of the components. Well, that's just going to be, I think, A. Data will be written to a new file. I guess that's W. And then existing contents will be read and new data will be appended. I guess that might be A plus. Oh yeah, okay, great. All right, so now this here is explaining that when you're doing these write things, the writes might not occur immediately. They're actually written into a buffer, and there's a bunch of writes, and it's not until a new line is written, okay, that the buffer is actually written out into the file, or if you close the file, then if there's anything in the buffer, it's written out, okay. But so this sort of illustrates that, and we see that see, this thing opens up a new file for writing, and then this thing it writes the word NUM into the buffer, but not into my text yet, not my file.txt yet. And then it writes a number 5 over there, but still doesn't write it into my file text. And it's not until this thing is encountered where it actually writes it. So that gets written in there, and then it decides to write it out. Okay, so you can make sure it writes out that way, or I guess you can include a buffering argument. Flush is the other way to do it. So if you want it to write, and you don't want to wait, until you either close the file, or you don't want to wait until you write a new line character, you can use this flush method. And it also says you may have to actually do that also. I'm not sure. You can experiment around with that, but you'd have to. I wonder how you'd experiment with that. Well, anyway, I think I can figure out a way to test that later, but yeah, let's see. I'm gonna well, no, we can test this later. Okay, so statement 2 will always, yes, it will, because you have to write a string, so it'll always produce an error. Yes, it always produces an error. No, it's not true that this happens. We just talked about that. It's false that it immediately writes data to a file. And the flush method forces the output buffer to write to the disk. Yes, that's true. All right, so the next section here, interacting with file systems. This just kind of, there's this OS module which provides an interface to the operating system, and it helps you get information when you're interacting with files. Okay, so like this thing, there's a os.stat with the name of a file there, will load this up with a bunch of statistics about the file. Let's see what happens when you run this. Okay, this loads that module. This opens up creates. This gets a bunch of information. It gets like the size, the access time, maybe the last time it was accessed or something. So these are examples of some of the methods. This is how the remove method in OS would be if you wanted to delete the file. So that's how you delete the file. All right, so there's this function called join, os.path.join, and you know, in some operating systems, you know, you would express the path to a file using backslashes like this, and in other operating systems, you might do a / like this, a single /. And what this os.path.join method does is it will you know, concatenate the you know, the directory name, the directory names, along with the file name at the end, if you want, and it'll concatenate these elements of a path together using the right separator. So so if you're on a Mac, it'll use the /. If you're on a Windows machine, it'll use the \, I guess. So so that's helpful. So here, if you know, you're creating the file path, and it's you know, directory called logs inside, or it's a file called log.txt inside of a directory called day, inside of a directory called month, year, and logs. And so this looks like this on a Windows machine. Oh, I know why it's // because if you want the \, to show, you put a \ in front of it using these quotes. But if you're on a Linux machine, use the same code, use the same line like this. It's just that this is going, when this is created, it's going to look like this. And then when you actually open the file using this path that you created, it will it'll look, you know, correct. It'll work. And you can also the separator is actually, you can refer to the separator like that, os.path.sep for separator. So if you take the path and you split it using the path separator, you of course would end up with a list that looks like this, with where each element of the list is the you know, the directory name or file name from the path. All right, so this would be you know, sub comma output. I think that's what it would be. Yes. Yeah. Oh, you're supposed to put the quotes? I was wondering about the quotes. Yeah, this has quotes there. So maybe this is wrong. Maybe it should be wrong. Anyway, let me try it. All right, so anyway, so these are some other methods that go along with path. You can do this path split. You can see if it exists, see if the path is actually a file. Get the size of it. Is that the size of the file? Returns the size in bytes. Oh, it's the length, the size in bytes of the path. Wait a second. It's the size in bytes of the file at the end of the path. All right. So this you complete these participation activities, and you get firmed up in your head these methods, these path methods. There's this function that will called walk that will let's see, do all paths, path files, OS, right to the hard drive disk. Yeah, I would say so. In this example, yeah, I mean, or it doesn't have to be a hard drive disk. It can be a USB drive too. I mean, anything that looks like that's referenced using the letter colon. But OS might offer other methods in there too. You have to search on it. Python OS import. Operating system name. Yes. Yeah. You have to say up at the top. You have to import it. So it's like it's like importing math or importing the other things that you need to import up at the top. Where is that? So so you have to have this. You have to do this import, and then you get all the stuff. All right. So this allows you to this provides a list, and it's sort of a list, I guess. Yeah, it's a list, and you get these three strings. It's more than that. These are lists. Directory name. No, this would be just a string, and this would be a list of subdirectories and a list of files, because inside a directory you can have a bunch of subdirectories and you can have a bunch of files. So inside a directory, okay, this directory has just two subdirectories, 1, 2. This directory has two subdirectories, 1, 2. This directory has got one subdirectory. Well, anyway, yeah, I don't see any. Doesn't look like there's any directories that have both files and directories in them. But anyway, all right, so that's yeah. So you can. There's other stuff. What is this? This is this where I just was? Yes, that's this. So yeah, there's other stuff that's in here. But yes, it looks like it all has to do with the file system. Pretty much. Okay, binary data. We don't have to spend too much time on this because it's kind of you aren't it's like an image, you know. If you try to open up an image with a text editor, it looks like, you know, it doesn't look like anything. Let's see, do I have an example here? Let me let's see, what's a nice picture? Okay, here's a picture. Can I copy this? Okay, so here's a picture of some clown here. And this is what it looks like when you double click on it. But if we try to open it up with one of our text editor programs like Notepad, see, it's all much. Oh, there is some XML in here. Oh, look at that. Some XML. But all of this stuff is supposed to be like the image. And so the text editor is going to try to make sense out of it, and it's going to map these bytes into what they would be, what the characters would be if this were a bunch of characters. But you can see it doesn't really make any sense at all. And so that's what this binary data is. Now, it talks about how to print, how to create files with binary data using, you know, characters, you know, codes and so on. Like if you want to create a binary, a bytes object, it's called a bytes object. It's an object that consists of just a bunch of bytes. And the bytes could be, you know, they could be bytes that are intended to be ASCII characters, in which case it would kind of be like it would be text. Or you can specify them just using the hexadecimal number codes. So here, for example, you're using this. Okay, so where does it say byte? Okay, here's an example of where you have you're specifying the bytes that make up that these ASCII characters would translate to, and you're storing that into this mybytes file. And when you look at it, it's just going to be the you can't really look at it with a well, actually maybe you could. So anyway, you don't really need to you should know about this, and if you ever decide you want to you know, if you ever end up being a programmer where you're writing code to manipulate images somehow, and then this stuff becomes important. But all the stuff that the vast majority of you're dealing with files is going to be, you know, with characters, and it'll be things like, you know, translating a comma separated values into and when you open it up with Excel, it's a spreadsheet, or just generating, you know, files with text in them. And if you deal with binary files, it's probably just a matter of like copying. You know, you're copying a binary file from someplace to the other, in which case you're treating it as, you know, the whole file at once. You aren't going to parse the file. You aren't going to look inside of it and just take parts of it out, unless you are familiar with how the bytes translate into a picture. You know, like a JPEG file is a bunch of bytes, and a GIF file, GIF file, is a bunch of bytes, and they both represent pictures, and they can be pictures of exactly the same thing, but the JPG representation is different than the GIF representation and the PNG, and that's why you'll notice a JPG file and a PNG file. They're both pictures of exactly the same thing, and they look just as good. But the JPG file is going to be much smaller just because of the way it translates the bytes into the image of the picture. So anyway, here is how you might specify a bytes object by just one byte at a time. It's going to say, you know, E60000 or whatever, you know, 04, 06, 04. Oh no, there's 300. Anyway, and so you can specify them that way. Anyway, so I'm not going to, you know, this. You should go through here and do these participation activities, but there aren't going to be any labs having to do with these. All right, command line arguments. This is pretty important. Yeah. So you know how when we run our Python programs, it's convenient to be able to, like if we're specifying files, it's convenient to be able to say, you know, Python, the name of your program, and then if your program is dealing with files, it'd be nice to name the file right after that, instead of asking the user, okay, instead of having a separate, you know, ask. So the way to get at these command line arguments, as they're called, command line arguments, is simply by referring to them this way, sys. So you have to import this sys class, and sysarg0 is the name of your program. Sysarg1 would be the name of the first argument, and sysarg2 would be a second one, and so on. So so that's very convenient. Here we're running my script, which I guess is this. First thing it looks to see if this sysargv list has two elements. It's got to have two elements. So the first element is going to be the name of the program, and the second element is going to be the name of the file. If it doesn't have two elements, then you didn't enter something. You entered the wrong thing. So so this prints out an error message, and this is this is I guess an error code. Doesn't show it over here. So anyway, this is here we're using the OS one to see if the path to the file exists, and that just tests to see if the file exists. So the file exists, and so it tries to open it up as a read, and so then what this does is it reads the two. It's going to have two numbers in it, yeah. This number and this number. And it's going to read them up as integers. It's going to, what is it going to do? It prints out it reads them up, and then it closes the file, and then it outputs, displays on the screen. It displays the first number. It says num1 is, the first number is 5, the second number is 10, and then it prints out the sum of the two like this. So anyway, so that's how command line arguments work. And then there's this with statement, which is kind of nice. It kind of takes care of, you know, opening up your file. You do a bunch of stuff to it, and then when the with statement is over, it automatically closes the file. So here for example, let's say you open a file for reading and appending. So you're opening a file for reading and appending. So you're going to read it up, and then you're going to write at the end of it, I guess. And so this opens it up, and then you refer to this object as F, and then this thing reads up the first line, converts it to an integer, and stores it in num1. This reads up the second line, converts it to an integer, stores it in num2. This multiplies num1 by num2 and stores it in a variable called product. And then this writes out product. This prints out a blank line, and then this prints out the product. And then you don't need to close it because the with statement ends. This is the last line of the with statement. Then when it drops down, then it automatically closes it. So that's kind of convenient. Okay, here's a comma separated values, and this a comma separated file, comma separate CSV. It's a CSV file. And the thing, if it's a .csv, then Excel recognizes it, and you can double click on it, and it should open up. And if the .csv is formatted properly, then it'll open it up, you know, as an Excel document, and the commas represent the columns. So in this CSV file here, we've got 1, 2, 3, 4, 5 columns, and column 1 is, and there's 3 rows. This is the title row, title of the columns. And then there's 3 rows in the spreadsheet, and the commas indicate, you know, separating from one column to the next. So the first one, this is the name. This is the name, and then this is HW1, homework 1. This is homework 2. This is midterm, and this is final. See, and then this is the next one. The next guy, Sam Tarley, and his homework 1 is 10. Homework 2 is 10. Midterm is 99, and final is 100, and so on. So each, you know, the file represents, each line represents a row, and the fields are separated by commas. Now, if you want to have a comma inside, then you got to put parentheses around the whole thing. So if you want to have PETR comma little, then you would just put a quote. You would put this whole thing in double quotes, like doesn't it show me? Here's an example. So let's say you wanted it to be like this. Last name followed by first name. What this is saying is that, well, one thing you could do is you can make it not comma separated anymore. You can make it semicolon separated, but nobody ever does that. What they do is they just put if there's a comma inside the field, then you put double quotes around the field. And if you want to have double quotes inside there also, you put a backslash in front of the quote. So anyway, so this is okay. So there's a module or a class that you import. It's called CSV, and then you're able to you know, here you're opening up a file as, this is just called CSV file. This is just still a file. It's not anything. You know, it's still just a file. But then you use this. You create a you take the file and you use this CSV. See, so this is a, all right, yeah, it's a static class, I guess. So if you use this this module dot reader, you use this method, then and an argument is the file that you just opened, and then you say what the delimiter is, and in this case it's commas. So it doesn't have to be commas. It can be tabs. Tabs are even, I think, are even a better delimiter, a tab, because you're never going to have a tab inside of a field. You know, you can have commas inside of a field, and you can have quotes inside of a field, but you're never going to have a tab inside of a field. So I like tabs better, but commas seem to be more common. But anyway, so what this tells me, what this tells you, is that you can choose any delimiter you want, and then you end up with this grades reader object, and you're able to iterate through the rows of the CSV file. And so here you're iterating through the rows of the CSV file. And this is here you're referencing the grades is, okay, so that's, oh, you're creating a dictionary here. Okay, anyway, yeah, you're creating a dictionary that maps student names and just list of scores. I see. So anyway, writing the rows to a CSV module, here you're importing the set of methods that you're going to use. You got a couple of rows here that have data like this. So you do this thing where you open up this file, which is as a write file, and you're going to refer to it as CSV file, and then you ask to use the writer method inside this CSV class that you imported over. It's got a writer method in there, and here this is a static class, which means you don't create an object. You don't create a CSV object and then use the writer method that comes along with the object. This is when you import the CSV class, you just use the writer. It's kind of like math. When you import the math class, then you're able to use all of the functions in the math class, all the methods in the math class, and you don't do it by creating a new object, you know, and then referring. You name the math class directly. All right, so this creates something that you can write. This creates the ability to be able to write to this file, and then here you use this write row method that is now available inside this. So this actually is an object, and there's a write row method that comes along with this object. And here you're writing out these rows, and these rows are lists. Okay, it's a list. You know, and the number and you know, it's a list of ordered elements, and the order is the columns. So you can do it this way. You can use write row, and you write one row at a time, or you can write a list of lists like this. You can do it like this if you want to, and there you're writing rows, writing more than one row at a time. All right, so here you can go through and do these, and then that will firm up how you actually use these this CSV class valuable. All right, it's 412. Let's do this first. Why is it showing me this? Be sure to configure. Am I in my right? Oh, I'm in the wrong book. That's why it gave me that message. Okay. This is next semester's book. By the way, next semester's book, if you take, I hope you guys all sign up for next semester. We're going to go further. We're just going to go, there's more stuff. And it's going to be the same kind of stuff, except for we're going to learn some more fancy stuff. We're going to go over some of the things, looking at it a little bit differently. Stacks and queues, which are types of lists. We're going to look at some sorting algorithms and so on. So anyway, let me go back to where I'm supposed to be. Here we are. It's this one. So 12. Okay, so this lab. Okay, here we're going to write a program. Write a program that first reads in the name of an input file. So it reads the name of the input file. I think I'm going to use the argv. I'm going to use a command line. When I'm writing this to show you, I'm going to use the command line. I'm going to specify the file at the command line. Okay, so what this does is you read in a file of words, and you store them into a list, or you iterate through them, and you when you read them in, we're going to use the readlines method, and we're going to create an open file object, and we're going to use the readlines method, which is going to return a list of lines, and each one of these is a line. And what we're supposed to do is we're supposed to go through it one at a time, and if it is between these words, then you print it out. Otherwise, don't. So it turns out that these are all alphabetical order. They don't, are they? Yeah, they are, but they don't need, doesn't matter. The algorithm still works. I mean, the way you're going to write the algorithm still works. They don't have to be in alphabetical order. But so you go through and you look at each word, and if it is greater than or equal to this word and less than or equal to this word alphabetically, then print it out. If it's not, if it's outside this range, then don't print it out. Okay, so that's all we're doing. It actually gives you a nice file here. You can download the file to try it. And let's do that. I actually downloaded it earlier, but I'm going to download this one on the desktop. I'm going to put it here. And so it's on my desktop someplace. And let's see where it might be. It's zip. Oh, here it is. And so let's open it up. And it just looks like this. And so I'm just going to drag this out and put it on the desktop. And it ends up over here. Okay, so this is a file, input.txt, that looks like this, lo and behold. And then I also have my test.py. Where is it anyway? Test.py. Here it is. It's right here. Here's my test.py, which of course is empty right now. It's this. Okay, so I've got test.py and input.txt. I've got them both on my desktop. And so I'm going to write this program. So first of all, I'm going to say file name equals, oh no, first I got to do import sys. File name equals sys.argv, is that right? 1. Is that right? I'm going to go to command line arguments. Sys, and it's argv, sys.argv, this. Okay, right. Okay, so now you don't want to do it this way because you want to ask the user, you know, separately, because you want to get all the points here. So in here you got to ask the user for it. But I'm just going to be fancy because I'm writing it separately, and I'm going to run it using my using this. Okay, so that's going to grab me my file name, and then I can ask the user for the low number, the low word, and the high word. So I'm going to call it the low word. The low word equals input, and then enter a lower boundary. And then I'm going to do high word equals input, enter an upper boundary. And then I'm going to, might as well read in the file. I'm going to call it a user file equals open, and that's, I don't think I need to import anything for open to work. I think open just, just always works, built-in function. And I'm going to open the file name. File name. I think I just got to do this, right? I think that's all I have to do. And then I want to get my list of lines. I'm going to say my lines word lines lines equals, I'm just going to do like word lines equals user file dot read lines. Okay, so that's going to take this file, which is connected, which this thing, in some languages it's called a handle. So this is a handle for the file. And that comes along with a method called readlines. So when you execute user file.readlines, then it returns a list, and it's a list of of lines. Each line is one word. Okay, so then I'm going to loop through for line a word. How about word in word lines? That loops through, and I guess I should. There's going to be each line has got a \n at the end of it. So I'm going to use the strip method to strip off that \n, and so we can use strip, Python strip. And so here we can strip. This strips all the blanks, and we want to strip the characters. So we want to strip the \, because it's going to have a \, at the end of it, because that's how it separates it. So let me just, I'm going to say word equals word.strip \n. That will strip that off the end of it. It'll also strip it off the beginning if there happens to be one on the beginning, but there shouldn't be. So now we have word with stripped of any line feeds, and then we can say if word is greater than or equal to low word, and word is less than or equal to high word. If that's true, then print word. Now, and then we should close the close. So no, it's a user file close. I think this should work. Okay, I'm gonna put say print opening file name. I'm gonna put that right here. I'm gonna print word lines so you can see what it looks like. All right, so I'm going to save this and I'm going to run it. CD desktop, Python test.py, and my file name is input1.txt. Enter a lower boundary. Let's see, what should I enter as my lower boundary? Oops, not that. That's what the list looks like. I think I'm going to enter Federation as the lower boundary, and the upper boundary I'm going to list Wilderness. Wilderness. Oh, okay, look, okay, right. So it opens that up, which I asked it to do here. Okay, so it opens it up. And then I read up all the lines, and this creates a list of all the lines, and then I'm going to print out all the lines. And here I printed out all the lines, and you see it's got a \n after each one of them. See, it's got this \n after each one of them. And I want to strip that off, and that's what this does. This is going to take the word one word at a time, and it's going to strip off that \n, And then it's going to say if it's less than or equal to that or greater than or equal to that, then print it out. And so that's why Federation printed out, because that's equal to the lower bound, and then it prints out these, and then ends at Wilderness because that's the upper bound. Okay, so you can see here now how the files work, and of course when you want to do this assignment, you don't want to, you have to paste something in here, and it better not be all this other stuff that's got all these prints here. And also, you don't want to read in the file name this way. You want to instead have file name equals input, just like that. Really, it should be like that, because this is what the input looks like. You type that. This is the first thing it asks for. This is the second thing it asks for, and this is the third thing it asks for. And then these are all in that file. And I put that file in the same directory, namely the desktop. I put that file on the desktop along with my Python program. So they're in the same directory. They're both on the desktop, and that way I didn't have to mess with the path. It's right there. All right, so I think it's 4:30. I think I will end for today, and we should be able to finish up the chapter on Thursday. And some of you have sent me some questions, and I'm sorry I haven't got to them, but I'll try to get to them later this evening or tomorrow for sure. So I haven't. I was started to do all the copy up all the grades. I think most of you are doing quite well. If anybody needs an incomplete, just let me know. And the book expires January 5th. So if you need me to help you with stuff, if you want an incomplete, I'll give you an incomplete, and then over the break we can jam on this stuff. And you got to get it done before January 5th, because everything has to be done in the book. If you end up not getting it done before January 5th, for incomplete, you actually have until March, but you'll probably have to buy the book again. Okay, so let's not let that happen. So anyway, I will see you on Thursday. Are there any questions?
Thank you.
All right, I will see you on Thursday. Thanks for watching.